For generations, a single day on planet Earth has been treated as one of the few absolute constants in human life. Every clock, schedule, and modern infrastructure system relies on a fixed, unwavering rhythm of exactly 24 hours. We calculate 86,400 seconds in a standard day, structuring our global civilization around that certainty. But breakthrough geophysical research has just shattered that assumption, revealing that the length of our days is officially changing. If you find this mind-bending planetary science valuable, please hit like and subscribe to Visual Link for more tech and science updates. Human-driven climate change has become so incredibly powerful that it is literally altering the physical rotational spin of our planet. A landmark scientific study led by space geodesists has proven that global warming is stretching time by slowing the Earth down. The current accelerating rate at which our days are lengthening is completely unprecedented in 3.6 million years of history. To understand exactly how rising temperatures can manipulate the spin of an entire planet, we have to look at fundamental physics. Think of a professional figure skater performing a rapid, blinding pirouette out on a perfectly polished sheet of ice. When the skater draws their arms tightly inward toward their chest, their rotational velocity increases dramatically, making them spin faster. But the exact moment they stretch their arms out wide, their physical rotation slows down instantly due to angular momentum conservation. Our massive planet behaves in the exact same way, shifting its weight relative to its central, north-to-south rotational axis. For thousands of years, immense blocks of water weight were safely locked away as solid, heavy ice caps resting at the polar ends. But as greenhouse gas emissions trap heat and drive global temperatures higher, billions of tons of this polar ice are rapidly melting. This melted water quickly cascades away from the Arctic poles, rushing into the global oceans and accumulating heavily at the equator. By permanently pushing this monumental fluid weight away from the Earth's central axis, the planet's physical inertia increases. And because the Earth now faces significantly more resistance as it rotates, it turns more slowly, actively lengthening our days. Right now, this climate-driven time dilation is adding roughly 1.33 milliseconds to our days every single century. While a few fractions of a millisecond sound completely trivial to a human life, the physical force required to cause it is staggering. Shifting our planet's rotation by that much requires moving over 1,000 gigatons of water away from the polar regions. To confirm that this shift was truly anomalous, geoscientists had to peer incredibly deep into Earth's ancient geological history. They achieved this by analyzing the fossilized chemical remains of microscopic single-celled marine organisms buried deep in ocean sediment. By decoding the historic oxygen isotope ratios in these ancient shells, they reconstructed precise global sea levels across multiple eras. They discovered that while Earth's rotation has naturally fluctuated over millions of years, the modern industrial spike is entirely unique. Historically, the single greatest force shaping the precise length of a day on Earth has been the gravitational pull of our moon. If you are enjoying this deep dive into how human activity alters the cosmos, please like this video and subscribe to Visual Link right now. The moon's gravity creates massive tidal friction against the oceans, causing a steady drag that slows the Earth over deep time. This lunar drag naturally lengthens our standard day by about 2.4 milliseconds per century as the moon drifts away. But if global greenhouse gas emissions continue on their current high trajectory, a shocking historical tipping point will occur. By the end of the 21st century, climate change will officially overtake the moon as the primary driver of time dilation. Under a high-warming climate model, the day could lengthen by up to 2.62 milliseconds per century by the year 2080. Of course, no human being will ever biologically perceive a day that has been stretched by a couple of milliseconds. Your natural circadian rhythm will not notice a difference, but the hyper-precise digital systems running our world absolutely will. Modern navigation networks, global internet routing protocols, and financial trading markets rely entirely on nanosecond precision. Our entire global infrastructure is fundamentally bound to atomic clocks, which track time using the steady vibrations of ultra-cooled atoms. But because human society still legally aligns global timekeeping with the actual, physical rotation of the Earth, a conflict arises. When the physical Earth slows down, its rotational position falls out of perfect synchronization with our ultra-stable atomic clocks. To fix this discrepancy, international timekeepers have historically been forced to inject sudden leap seconds into universal time. But these manual leap seconds are an absolute technical nightmare for modern computer networks, often triggering massive systemic bugs. If the planet's rotation rate continues to fluctuate unpredictably due to melting ice, satellite navigation will require constant corrections. A discrepancy of just a few milliseconds can throw a deep space probe or satellite telemetry off course by hundreds of kilometers. This time-stretching phenomenon serves as a profound warning sign regarding the true scale of modern environmental disruption. The exact same massive redistribution of water weight that slows our planet is simultaneously fueling devastating global coastal erosion. It is even shifting the physical orientation of the Earth's axis, causing the geographical poles to drift along the crust. For centuries, humanity viewed the Earth as an infinite, unshakable bedrock that could easily absorb any amount of industrial pollution. We treated global warming as a localized issue of atmospheric temperatures, weather anomalies, and slowly rising ocean tides. We never truly imagined that our industrial footprint could be vast enough to alter the celestial mechanics of our entire world. We are no longer just changing the chemistry of the air. We are actively altering the physical rotational momentum of the crust. We are quite literally changing the cosmic tempo of the Earth, stretching the very fabric of how we measure a single day. Every single ton of carbon dioxide trapped in our atmosphere forces a cascading chain reaction through our global geology. From the very top of the atmosphere, down through the warming oceans, and deep into the solid rotational dynamics of the planet. This discovery adds a profound and chilling layer of urgency to ongoing international debates surrounding global climate action. Mitigating emissions is no longer just about preventing heavy storms or saving endangered coastal cities from rising sea levels. It is about preserving the ancient, steady astronomical rhythms of the planet that have guided terrestrial life for millions of years. Stabilizing our climate means stabilizing the very rotation of the ground we walk upon and the absolute time that we keep. Until we achieve that structural balance, our modern technological systems must actively prepare to adapt to a shifting planet. Engineers must design entirely new, highly adaptive time-keeping frameworks capable of absorbing these climate-driven microfluctuations. This will ensure that our global positioning networks, telecommunications, and space missions remain perfectly accurate into the future. The 24-hour day has been humanity's ultimate temporal anchor, a steady heartbeat through every single era of civilization. But as the boundaries between human industrial activity and planetary physics continue to completely blur out across the globe, we must face the profound reality that even time itself is no longer immune to our massive collective footprint on Earth. The planet is slowing down because of our actions, and the future depends on how we choose to respond to a changing world. Thank you for watching this special report on Visual Link. Be sure to share your thoughts in the comments down below. We must continue to monitor these subtle planetary shifts as they hold massive implications for the future of our digital world. The physics of our planet are tightly bound to our environmental choices, proving everything we do has a cosmic echo. By safeguarding the climate, we are quite literally safeguarding the stable passage of time for generations to come. Let us know in the comments how you feel about the fact that global warming is changing the speed of the Earth's rotation. Your support helps us bring you the latest breaking news from the worlds of quantum physics, climate science, and advanced engineering. We will see you in the next deep dive documentary as we continue to unpack the mysteries of our changing universe. Always remember to keep questioning the world around you, because science proves that even the most fixed realities can change. From the core of the Earth to the upper atmosphere, human industry is writing a brand new chapter in geological history. We must meet this unprecedented challenge with bold innovation, rigorous research, and international policy cooperation. The clocks are ticking just a fraction slower today, a quiet reminder from the planet that we must act before time runs out. As always, thank you for tuning into Visual Link, and we look forward to exploring the next scientific frontier with you. If you want to support more independent, deeply researched science documentaries like this, please smash the like button right now. Don't forget to hit that subscribe button and turn on the notification bell.